Hi, in this video we are going to talk about data structures in the main and of course why to use data structures. So let's get started. I'm sure that you have posed the question several times that why do we need data structures? Why is it so important to bother about the concrete implementation of the data structures and to study about the internal structures of data structures? Okay, so what are data structures for? Basically, data structures are to store data in an efficient way. And basically, the most important word in this sentence is the efficient. So, okay, we can store data in several ways, but it's very important that with the help of data structures, we are able to store data in a very efficient way. So, why to use data structures? Because we often have the intuition that we want to make an algorithm fast, then we have to optimize it. We have to write it in C++ or C, and it's going to be the fastest algorithm possible. We just have to avoid nested for loops and to make sure that we make every calculation as fast as possible. But basically, algorithms can be boosted up by proper data structures. And when I first met with data structures, it was quite counterintuitive to me that okay, with storing data in an efficient way, we can boost up algorithms such as the algorithm behind the GPS, shortest path algorithms, spanning trees, and so on. So data structures make sure that the running time will be better for an algorithm. I think a good example is the Facebook application. The engineers have to use proper data structures because more than 1 billion users are present on Facebook. So they have to manage such a vast amount of users that have to track their friends, have to track their posts, their likes and whatever. So the running time for manipulating such huge data does matter. For example, if we would like to sort 10 items, of course, basically we could use bubble sort, we could use merge sort or whatever. Basically, it doesn't matter. When we would like to sort 10 million data items, for example, person in a country, then of course it does matter whether we are using bubble sort or merge sort. So basically, when we have a huge data, in these kinds of situations, it's going to be important what data structures we use, what sorting algorithms we use, how we manipulate the data, and so on. So let's consider two important examples. First, the Dashcraft shortest path algorithm. Without a proper data structure, a heap or a priority queue, the running time would be quadratic, so ordo n squared. So we would like to find the shortest path in a graph where the number of edges is equal to the n, then the time complexity of this algorithm is going to be ordo n squared. The priority queue approach makes sure that the running time will be far better, ordo n log n. And if we have a huge data set, so the n is equal to a great number, then of course it's going to be very important to use n log n algorithm instead of the n squared. Or for example, let's consider the other important algorithm. By the way, we are going to talk about these algorithms later. So for example, we would like to construct spanning trees. Then we can boost up the algorithm with the help of priority queues again. So the running time of the algorithms are determined by the data structures we use. And basically, that's why it is very important to use good underlying data structures. Thanks for watching.